Hello, welcome to this video. This is lesson 5-5. We are going to talk about the general power rule for integrals, and it's kind of like the reverse chain rule. You're reversing the chain rule, right? So we'll talk about what we do with the chain rule for derivatives and how that applies to integrals, and we'll take a look at how to do that. In the next video, we will talk about U substitution, just kind of a general format or a different way of doing reverse chain rule. All right, so without further ado, let's go ahead and get to it. Okay, so in lesson 3-3, we learned how to go ahead and utilize the chain rule, right? So if I was taking the derivative of, say, a function raised to a power here, so d dx, okay, of u raised to n power, you use the power rule, right? You bring down n, you drop the power by 1. Now, if I had an interior kind of a polynomial or some type of function, okay, I have to take the derivative of that, right? And that is u prime. Okay, so we're just going to do the opposite when we integrate. Now, in order to go ahead and use the general power rule for integrals, okay, in formula called the reverse chain rule, you're gonna need to identify, okay, what is that like little chain that's linked on, or the hook on factor, right? So when we integrate, I'm gonna have a function and we're gonna be looking for the hook here, okay? So if I have u to the n and u prime, okay, and I want to integrate that, then that is equal to u to the power of n plus 1 divided by that value plus the constant, okay? This looks a lot like the simple power rule for integration that you learned in the last lesson, okay? But again, you must have the hook on factor u prime, okay? So let's go ahead and start out with our prior knowledge here. If I want to differentiate 1 plus 5x to the power of 4, okay, that's going to be 4 times 1 plus 5x to the power of 3. But notice I have a value on the inside, 1 plus 5x. Okay, I can differentiate that. So I'm going to multiply by the derivative inside, which is 5. Okay, so note, now we want to integrate 5 times 1 plus 5x to the power of 3. Okay, so what I'm gonna need if I want to differentiate 1 plus 5x, I'm gonna need to take the chain rule the inside, right, which is 5. Okay, I'm gonna take the chain rule, utilize the chain rule, sorry. Okay, so the hook on factor, right, so the hook for this is this. So if I want to go ahead and integrate, I can do that. There's my hook on factor. So this is equal to 1 plus 5x. I can raise the power of 4, right, and divide by 4. Okay, and don't forget plus c. So there is the integral of that value. Okay, and maybe you're like, hey, where did that 5 go? Well, we undid that hook on. Okay, so imagine, like, what if I wanted to differentiate this? Okay, well, I would have to go ahead and utilize the power rule. The 4s would disappear, and then you'd have to take the derivative of the inside, which is 5. Okay, so there it is. All right, and that's what this is saying. Note, you hooked on the derivative of the inside of the power function in example 1, so we had to unhook it in example 2. All right, let's go ahead and look at some various examples. Now, in number 3, we're going to do just the same thing, okay? So I want to go ahead, I want to integrate this, but note on the inside, okay, this power function. Computer's not liking me. Come on, computer. Okay, I think I fixed it. All right, so I want to go ahead, I want to integrate this function. So what I'm going to need is I'm going to need the hook on factor from this function. So note, if I was to differentiate this inside, the hook on factor would be 3. Now notice I don't have a value of 3 like being multiplied with this function, so I have to introduce it. Okay, so I'm going to go ahead and I'm going to rewrite this. And I'm I'm going to write right here 3 times 3x minus 1 to the power of 10 dx. So now I can integrate this. But hold on, Schwarber, can you just introduce numbers wherever? And the answer is no, I can't do that. I have to multiply by a factor of 1. So how do I multiply by 3 but keep this 1? Well, I'm going to multiply on the outside by 1/3. So it's the same thing, right? 1/3 times 3 is 1. So I'm really only multiplying by 1. But what I have now is now I can go ahead and integrate this. I have 1/3, okay, times, I'm going to have 3x minus 1. I'll raise the power by 11 and then divide by 11. Okay, and I will add c, and there is my answer. Pretty cool, right? Math magic. Let's go ahead. Oh, just kidding. Going over here. Number 4. So on number 4, again, I'm going to identify the hook. When we see these problems, they're generally testing your knowledge of this. Now, if you look at this function, right, notice it has a higher power. Okay, I can go ahead and take the hook, and if I take the derivative of the inside, that is 3t squared plus 2t. Well, hey, don't you notice that this is this here? Okay, so you have your hook. All right, and just kind of envision that I have a power of 1 right here. So when I integrate this, this is going to be t cubed, can't even talk, t cubed plus t squared raised to the power of 2. And we'll divide by 2 and add c. Okay, so there you have that one. Integration. All right. Ooh, look at this ugly monster. It's not that bad, I promise. Just rewrite it. Make this guy look, or girl, not so ugly. I won't assume gender here. So we have 6x squared times 4x cubed minus 5 to the power of negative 1/2 dx. Okay, and again, what we're gonna look for off to the side is the hook. So if I want to integrate this, I need a hook because I have some power functions going on. So I'll take the derivative of the inside here, and that is going to be 12x squared, right? 3 times 4, drop the power by 1, 12x squared. Now, do I have 12x squared? The answer is no, I don't. But what I do have is I do have a 6x squared. Okay, so what's missing? Well, I just need to double it. I need to multiply by 2. So I'm going to go ahead and I'm going to do my math magic. Okay, if I multiply by 2, if I make this a 12x squared, I have to go ahead and keep it a 1. So I'm going to divide by 1/2 on the outside. Is that legal? I will make it legal. That's a little Star Wars reference right there for you Star Wars nerds. What's up? Okay, so now we can go ahead and we can, oh, it's negative. We can integrate. So I'll take my function, 4x cubed minus 5, raise the power. Okay, and this is being multiplied by 1/2. And when we raise the power, we have to divide by that same power by 1/2 plus c. And if I just simplify this, these 1/2s cancel, and we get 4x cubed minus 5, boop, plus c. And there is your integral, okay? Your solution to the integral. All right. Number 6. All right. So this one, they're being really tricky here. Now I want you to notice. Okay, here's the power function, and I'm gonna look for the hook. Looking for the hook. Hook. And the hook is 3y squared. Now notice I don't have a y outside, and with math magic, notice in these past examples I've only been able to introduce numerical values, right? I haven't introduced a variable anywhere in these. Okay, I can't introduce variables. There's no way to do this. So I'm kind of out of luck. So what I'm going to do is I'm going to do what we did kind kind of in our early days of taking derivatives. I'm just going to expand this from exponential form to expanded form, and I'm going to go ahead and I will multiply. So we get the integral of y to the 6th plus 2y cubed plus 1 dy. Okay, and we're going to integrate normally. We're just going to be regular plus, this would be, what? 2y to the 4th divided by 4th plus y plus c. And we can adjust this. So 1/7 y to the 7th plus y to the 4th over 2 plus y plus c. And there you have it. All right. Okay, so that's it for this video on using the reverse chain rule, kind of unhooking stuff. Next video, we will talk about U substitution. Catch you next time. Peace.